CC-IN2P3 on prospects and needs for iRODS at the French International Institute for Nuclear Physics and Particle Physics.
Thank you. Do you hear me? Yeah? No? It's okay? Okay. Now? Okay. Okay, I'm going to talk about, in a couple of minutes, about the prospects and needs and the way we are using iRODS at CC-IN2P3. So I will give you a short overview of what we're doing with iRODS, who we are, and where we're heading. And so things we would like to have in iRODS, which are not there at the moment, and the things that we are going to need in the near future, and how we are going to use iRODS as well. So who we are. So CC-IN2P3 stands for Computing Center for the National Institute of Particle Physics and Nuclear Physics. We are located in Lyon, and we are part of this national institute with many labs which are involved in international collaborations. We're not doing any research, but we are providing services, so batch services and any computing services to the community. So the French community, but also the international collaboration for which we are working as well. Well, iRODS is being used in for different topics. We are using iRODS to do some kind of data preservation, but I don't like to talk about data preservation because it's not real data preservation at the moment. I will go back at the end on this point. We are doing data sharing and management and distribution because our users are located anywhere, mainly in Europe, but also in the US or in Asia, for example. So we have to share and to provide the access to the data from anywhere. So the main customer of the high energy physics community, so the Babar experiment at SLAC in Stanford University, astroparticle experiments, astrophysics, as well as biology. We have a little bit of biology in genetics, ecology, biomedical application, and arts and humanities as well. Who is using iRODS? So the experiments projects are spread worldwide. Basically, it can be experiments on the ground, under the sea level, like Antares in the Mediterranean Sea. So it's a neutrino physics experiment, basically studying high energy neutrinos coming from space. We have experiments who are using iRODS who are located in remote areas like in Argentina, like Auger experiment. Where's the pointer? Yeah, see here. And also it's being used by, for AMS, which is on the International Space Station. So data are produced and we have a version of the data, raw data, as well as Monte Carlo production, which are being made also on our side. So in a couple of numbers, we have 23 zones, 41 physics groups using the system at the moment. Roughly 500 users, a little bit less, but that's iRODS users. So some iRODS user accounts are generic accounts, and there can be many, many users under this kind of generic accounts, up to, well, 800,000 connections per day, 8 million of files registered at the moment. We don't have lots of files because usually we are managing to have big files and handling big files. At the moment, we are iRODS is managing a space of 9.7 terabytes of data. Part of on disk and the other part on tapes. So we have a system where we are mixing disk and tape with migration from disk to tape or from tape to disk. Because tapes are not only being used for archival purposes, but also as a nearline system. So data can flow around from disk to tape, etc., etc. So we can have a growth of up to 30 terabytes per day. At the moment, it's rather quiet. It's just, I think, 9 terabytes per day. So it depends on the activity of the experiments. In terms of architecture, we have on the front end 2 iCAD servers, which are basically exactly the same. So why do we do that? It's in order to have a service which is redundant. So basically, if even one of the servers is dead, there's still one server, which is one iCAD server, which is available. And they are accessed through a DNS alias. So we are sure at any time the service is available. So as for the clients can be local client or client spread anywhere around the globe. So it's being accessed by batch systems, the local batch system, but also remote batch system. Like we have many connections, for example, from Italy, from Holland, from Japan, anywhere. So we have thousands of clients who can access the system at a given time. So as a backend for the iCAD, we are using Oracle rack in order to have scalability and having also a system which is redundant. For the disk space capacity at the moment, which is in front of the tape system, so we have a bit more than 800 terabytes of disk space on DAS servers, which are on Dell hardware at the moment, and which are enough for the kind of usage that we are doing. And these servers are connected to our mass storage system. The mass storage system at the moment has a theoretical capacity of 320 petabytes. We have 28 petabytes at the moment being stored. So on these 28 petabytes, there are 9 petabytes stored for iRODS. So back and forth every day, it can be, you can have a traffic of more than 10 terabytes, even more. So we can have clients from the outside who are wants to retrieve data which are on tapes. So they don't see that the data are on tapes, so the data are automatically staged from tapes to disk before being shipped to the clients remotely. So I'm not going to go into the details about what we're using exactly with iRODS, but I'm going to show you a little bit about what we need, where we're heading, especially something which is very important, and it's connection control, because we actually don't have any control on the connections. So basically, we can have many users accessing the system, but we don't have not necessarily any clue about how they're going to access the system at a given time and how many clients are going to access the system. Because we can have, let's say, 2 weeks ago, we had a cluster in Holland who was accessing heavily the system. And that can be an issue on the iCAD servers in terms of connection, because each time you're going to spawn many iRODS agent at the same time. And so it's very important to have some kind of control on the hardware being used. For example, that's a graph about the usage of a memory for one of the iCAD node. So usually it's okay, it's around 4 gigabytes. But sometimes, because there's a massive amount of connection happening at the same time, it just blows up, because you consume all the memory capacity of the server, and the server is dead. it's okay because there's still another server which is doing the same job, so the system is not in danger. However, it's not a very good situation because you end up with a server that you have to really reboot. This is why we're using the connection control. This is something we discussed a long time ago with Michael Wan, who was the person who designed the connection control, and he came up with this solution, which is nice, and that we're using now to mainly control the iCats. So we're sure we're not going to blow up the system. But some improvements are needed, especially because at the moment the way it is being done is very rough. So if we reach the limit, let's say 200 connections at a time for a given zone on a given server, every new client is going to, who is going to attempt a connection is going to be disconnected with an error. And I don't think it should happen. It would be nice to have some kind of queuing system. And then in order to kind of throttle the amount of activity on the server. Well, already 5 minutes. I have I'm in a rush now, so. And the problem is if you have a privileged user who has to do some administration work on a connection control on the system, he cannot even connect to the system because the resources are exhausted, which is not a good thing. Rule management is something very important. We're using rules a lot for data management between disk and tape for migration. So migration, also metadata extraction, and we can have in the queues up to 10,000, even more. I've seen sometimes 50,000 requests in the queue of the rule engine server. But some rules can have some higher priority, especially when dealing with a disk cache system. And the thing is, in that kind of case, these are the ones which are really important. So we need some scheduling priority. I'm not meaning about some fancy scheduling like you can have in a batch scheduling system, but something which helps us to have some kind of priority amongst the rules. And also a way to specify the rule name, having a rule name attached to a given task, which is easier to handle the rule. Especially you can have a rule which can have some input parameters, and you can have several versions of the rules running at the same time, but with different parameters. And the only way to try to make a difference between the different rules is to have a name attached to that, like you have with a batch name, with a job name in a batch system. And also to have the rule information stored on a local file system. It could be in a database. On the client side, Windows support is important, and well, it's very nice because we are running in a platform which is multi-platform. We have Linux, but we can have users in using Windows, having a Mac, etc., etc. So we have still some Windows users, and Windows support will be great. GUIs, at the moment we're using, well, users are using, for the ones who are really using GUIs, like the old Windows Explorer, we have the old PHP browser being used. We're using APIs, PHP, jargon APIs, so Java APIs, a little bit of C APIs. Bulk download, something important with small files when you have to download a huge amount of small files. Bulk download is very important in order to make something which is more efficient in terms of bandwidth usage. Okay, that's one browser that a colleague here, Pascal Calva, has developed in 2008, which has a browser, metadata viewer, and also you can view the data. Here it's a slice of a wild boar. It's an MRI of a wild boar. So what might be interesting for iRODS? Not necessarily for us, but I think could be valuable for the community. On-the-fly compression for upload, download, file versioning for people who can't afford small site, especially who can't afford a backup system. Having that would be an extra value. Automatic replication of hot files which are being accessed a lot, and between two resources would be okay, would be a great thing. We have our own monitoring tools with like Nagios, Elasticsearch plus Kibana, but for a small site, and if we are integrating small sites into our iRODS zones, everybody cannot afford to have Nagios and all the kind of stuff, so it would be nice to have something like we've seen this morning with the EMC presentation, for example. So for us, the volume is going to increase at a linear growth now, since we have iRODS in production since 2008, and we're going to reach 10 petabytes rather soon. There's massive migration to version 4, which is on its way. And I think one of the goals is to provide some RESTful interface to all our storage systems. And the way to do that is through iRODS would be a good solution. A medium-term archival service also built on iRODS. We are doing bit preservation, but that's not enough. We have to provide a medium-term archival system. So iRODS is really the perfect tool for this kind of things. Scalability, we don't have scalability issues at the moment. So, and we are very happy with iRODS, but ways of controlling, like Apache servers are doing, controlling the load would be a good thing. And I'm feeling the rising competition of cloud technologies. Well, computing world is like a bit like a fashion week thing. So yes, everybody's talking about cloud. Okay, but usually tools we are talking about, like Swift from OpenStack or other tools doing drag and drop, are very nice, but they are not doing the job that iRODS can do. But that's something that, well, it's for some people it's hard to understand because they want to go to the cool thing. The cool thing at the moment is cloud technologies, and but iRODS provide much more, and we need much more than just simple put and get. And that's it.
We have time for some questions.
So I would like to ask you about the priorities, so the rules that you need. Like what kind of prioritization, like a simple integer-based prioritization or user-based prioritization, or like which one is your most pressing need, or resource-based prioritization?
Can you repeat the question? I didn't understand it quite at the beginning.
Prioritization.
Oh, just
or just integer-based, like user submit an integer priority level.
I think this thing would be fine. Yes.
The integer-based one?
Yes.
Okay. Thanks.
And with, of course, the administrator who can run over some choices of the client. Well, at least maybe I think the administrator being able to bypass the priority of the user.
I had a question as well. You said you were looking at implementing a REST interface on top of, is that on top of iRODS or on top of your storage systems that are
on top of our storage system? So which means, and we want to put iRODS in the middle because Mike Conway has already developed a RESTful interface with Java on top of iRODS, and we would like to take benefit of this kind of efforts to provide a service to our clients. Because it's not because it's an urgent need, but again, it's a little bit political from my point of view. It's like cloud computing. Everybody is talking about HTTP, REST. But anyway, I think it's an interesting thing to have to provide a simple way to interface a client application of any kind with our storage system, and we could provide it in an easy way, and it couldn't with little effort on our side.
Got it. So data will be ingested over REST then, and in the same way that you're using file systems today. That's what you're saying then.
Yeah.
Okay. Good.
Let's thank our speaker.